We're asked to calculate the volume of some quantity of gas at STP. So we can use our shortcut here that 1 mole of any gas at STP has the volume of 22.414 liters. So if we start with 29.0 grams of methane, we convert that to moles, 16.05 grams per mole of methane. And now, since we're at STP, we can simply multiply that by 22.414 liters to get a value of 40.52406 liters. We're going to be limited to 3 sig figs because of this number here. And our final answer is thus 40.5 liters. Alternatively, let's suppose we forgot that little useful factoid. We can use the ideal gas law. We solve the ideal gas law for volume. We have the volume is equal to nRT divided by P, and we plug in the appropriate values. We're not given n number moles of gas directly, so we'll have to incorporate that. So we have 20.9 grams. We know that for methane, 16.05 grams is equivalent to a mole. So this taken together is going to give us our value of n, our number of moles. R and T has to be Kelvin. At STP, it's 273.15 Kelvin. And our pressure at STP is 1.00 atmospheres exactly. So looking at our units, we see that grams cancel, moles cancel, atmospheres, K cancels, and liters survives, which is what we want in terms of our units. So we have our volume is equal to 40.52406 liters. We can only use 3 sig figs because of our mass number here. So our final answer is 40.5 liters. Okay, we can take multiple paths to solve the same problem.